Hello everyone, welcome to the lecture series on Renewable Energy Engineering. I am Trivedi, Assistant Professor in Mechanical Engineering Department at LJIET Institute of Engineering and Technology. Let us carry on our chapter named Solar Energy. So in this session we will continue our study about application of solar energy. So let us start. Now, if for the starting, let us take solar refrigeration and cold storage system. If I have to explain you with, I just want to share you, in my older college, there was the solar refrigeration system in which we will get the cold water. Okay, for the student purpose. So it is really very good. Yes, obviously, as we are using some our domestic refrigerator, we will get the maximum up to minimum temperature we'll get the water. But in this case, we'll get nearly 2 to 5 degrees centigrade water, and it is really very good. Now, one of the most important application of the solar energy is the solar refrigeration and cold storage, which is really very important. Now, solar refrigeration and cold storage is used to preserve the foods, vegetables and other things. It is also used to run the refrigeration plants to generate the cooling system and to get the cold water also. Now, in this, as you know in the figure, there are nearly 4 to 5 different equipments. As we have already used a solar heating system and so more, just one component is added, which is the condenser. So what we were used in our solar water heating system, just as the solar refrigeration, like flat plate collector, then absorber, okay. In addition to it, we have to use the ammonia generator, then condenser and evaporator for solar refrigeration purpose. Because it is the refrigeration technique, we have to do the reverse process. Hence, it is required. Okay, now let us have, generally flat plate collectors collect the solar radiations and heat the circulating water, which is flow into the ammonia generator. Now, the ammonia liquid in the ammonia generator is heated and ammonia gas is separated. Okay. Now this ammonia gas flows to the condenser where the cooling water is circulated. Now cold ammonia gas is then converted into the liquid ammonia, which is then passing through the expansive valve. The pressure of the liquid ammonia is reduced and the expansion valve to the expansion valve, and immediately it starts absorbing the heat from the surrounding in the evaporator. As the result, the cooling effect is produced. Okay. Now, this cooling is used in a space cooling system. The evaporated ammonia is back to the absorber where the cooling water absorbs the ammonia, and again ammonia solution is prepared. So likewise, by using the ammonia, by using the evaporator and the condenser, we can easily get the heated liquid water into the circulating colder air. Okay, so this process is repeated in a cold storage as well as refrigeration and so on. So it is basically depend upon proper refrigeration fundament. Likewise, in our domestic purpose, we use the electricity. Okay, and by that electricity, we will give the reverse effect of cooling, of the cooling effect. Okay, just like air condition and refrigeration, we can use the solar refrigeration system. Now, let us study about the solar furnace, which means the power of the sun rays may run the furnace. We just check it. Now, as you see in this diagram, the solar furnace is an optical system, based on the optical system, where the solar radiation is concentrated to the very small area to obtain a very high temperature. It may consist of a solar energy concentrator of a paraboloid type, as you see in the diagram, and the reflector known as heliostat. Okay, now solar furnaces are used to study the chemical, the optical, the electrical and thermodynamic properties of material at a very high temperature, about 3500 degree centigrade temperature. Now, what are the advantages of solar furnaces? So they are comparatively simple design. They have high heat flux. They have no contamination and a continuous observation, and it is true in the absence of the electromagnetic field. It can run in any condition, any climate, any region. Now, what are the disadvantages? First of all, what do you think? What should be the disadvantage? Obviously, initial cost is high. Okay, the next, suitable only for intermittent operation due to the restricted availability of sunshine. We have to use it when there is the sunlight only. Now, high temperature is obtained on a very small area of about 2 mm, and the temperature gradient in the focal point is also very high. So it will give us the rapid heat, because we are using the paraboloid concentrator, and by using the paraboloid concentrator it will focus on one point and it will get maximum heat. Okay, hence solar furnaces were used where there is the maximum sunlight available. So they are only the optical type of system, and we cannot use it for any other baking system or for making glass wool or anything else, but we can use to study for the chemical, optical and electrical system. So this is basically the study type of a system which we have to understand. Now, let us explain swimming pool heating. Nowadays it is used in the areas where there is the colder, where they are the colder areas. We are using this solar pool heating system. In this, we need to heat the swimming pool only by the use of the collectors. This is the very simple method. Now let us check how it works. Let us explain the methodology. So here, one of the application of solar energy is heating. Okay, now heating the swimming pool. Now swimming pool can be heated by both passive and active system. Now the temperature that is required to be maintained in a swimming pool is normally we have to say 20 to 30 degrees centigrade, not more than that. For the lower temperature, simple solar collector with a high efficiency is used. Okay, because for bathing or for swimming inside it, we only require maximum 30 degrees centigrade temperature. What? Okay, if it is more than that, it may burn our skin. So that the main advantage of solar swimming pool heating is that it does not require any heat storage system, because pool water itself works as a heat storage medium. Okay, now inner surface of swimming pool is preferably black colored to absorb the solar radiation. Obviously, because we need to absorb the solar radiation, it should be like that. Now, solar radiation reaches the bottom of the pool and finally it absorbs the radiations at the bottom surface. Some of the radiations are absorbed by the water of the pool and it loses, be minimized by using the layer. Okay, so by the direct radiation, by paint with the black color, we will get the solar pool heating system. Now, if we say about some passive system, so for the passive system, we have to put the solar concentrator at the top of it, so that it may get the radiation value. As you see, it may receive the radiations and water inside the tubes may heat it, and that water will flow inside the swimming pool. So it will get, if there are the sunshine or later sunshine hours like evening, we will also get the heated water. This is just the solar swimming pool heating. Now, let us have the solar power generation system. So, let us explain it. What is the solar power generation? So, first of all, the generating station with the utilized solar energy of the sun, we have to generate the electricity. Okay, now this heat can be used to generate steam and electric energy and can be produced with the help of turbine generator set is called solar thermal power generation. Okay, generally we are divided in basically two categories. Likewise, low temperature power generation and medium temperature power generation, as well as there is the another one which is the high temperature power generation system. So they are basically of three types, which is low power generation system, medium temperature generation system and high temperature generator system. So now let us have low temperature generation system. As you see in this diagram, first of all, we are discussing about the thermal power generation system. Okay, so for this thermal power generation system, we need to use some turbine, we have to produce the steam, we have to generate the electricity by producing the steam. Okay, now if we are considering low power generation, it means less than 100 degrees centigrade temperature is there. Now water is heated by an array of a flat plate collector. We have to use the array of the flat plate collector to obtain the maximum temperature of the system. Now hot water in the temperature about 100 degree, not more than it, is stored in the thermal storage tank, which is well insulated. The heated water flows to the vapor generator, through which the working fluid of Rankine cycle is also passed. The fluid has a low boiling point and it is vaporized at about 90 degrees centigrade and has pressure of a few atmosphere. Okay, this vapor leaves the generator and execute the Rankine cycle by flow through a prime mover, condenser and the pump. It means it is a simple thermal system which generates the electricity based on the Rankine cycle. Working fluid is generally methyl chloride, etc. We are using the methyl chloride. Why methyl chloride? Because at a very low temperature the vapor is generated, and by that vapor we can run the turbine and we will get the electricity. Now let us check the medium temperature system. Medium temperature or moderate temperature is approximately about 400 degrees centigrade. Okay, to achieve this temperature, the line focusing the paraboloid collectors are used. So we have to use the paraboloid collectors because we require 400 degrees centigrade temperature. The efficiency of such a collector system is around 0.7%. Obviously, they are also based on the Rankine cycle, and the Rankine cycle efficiency is nearly about 0.38. So overall efficiency, efficiency of collector is 0.7%. Efficiency of Rankine cycle is approximately about 0.38%. So overall efficiency of this system is about 0.25%. Okay, so 0.25. So approximately 25% of the system energy can be generated. Now let us have the high temperature system. For the high temperature system, it has two concepts. One is paraboloid disc and second one is central receiver. Okay, now let us first understand the paraboloid disc. Now paraboloid disc, it means we have to use the parabolic type of disc. Okay, so sun radiation is brought into a focus point by using the paraboloid collector disc. Okay, the fluid passing through the receiver, as we have already studied about the paraboloid disc, I do not need to explain it in a further. You have to see that video in which I have discussed about paraboloid disc. So there is a receiver in between. So the receiver is heated up and it is used to drive the prime mover. Stirring engines are favored as a stirring engine, generally known as the prime movers. The system has the efficiency of nearly about 0.3 and it develops the power as 5 to 50 kilowatt. Okay, so such power plants can satisfy the need of small countries in remote areas, not for the urban areas. We can use the other ones. Now, central receiver power plant, as you see in this diagram. Solar radiation reflected from the mirrors called heliostat. So we have to use the heliostat system in here, and it is concentrated on the receiver provided on the top tower. Okay, the fluid flows through the receiver, absorbs the heat of a concentrated radiation and transport the ground where it is used, and it is used the Rankine power cycle. So it is the central receiver plant where we need to use the heliostat, and by using the heliostat and by using the Rankine cycle, based on the Rankine cycle, we will get the power. Okay, now next one is solar photovoltaic power generating system. If we consider the array structure of the solar cell, it will be in, there are basically three components. Let us check it. First one, which is structure and installation. Second one is power conditioning and control. And third one is storing battery. Hence I put a step of it. First step should be the structure and installation. Second is power conditioning and control. And third is storage batteries. So first we have to install the structure. Then we require to control and generate the power. And by generating the power, we have to store in the battery. Okay, so now let us start first system, which is a standalone system. Okay, so solar cell array consists of an appropriate number of cells, okay, connected in a series or parallel to produce a required voltage and current. Whatever is our requirement, we have to put the solar cells in array, maybe in a series or in a parallel way. The array is oriented to collect the maximum solar radiation around the year. So we have to calculate around the year system. As we all know, during summer we'll get more power, during winter we'll get lesser power, and during monsoon we get the power, we may not get the power. Okay, so it is in between. Now, in this system, the power conditioner regulates the output and array. It protect the batteries and provide interface between load and array. Now as you see in the diagram, an inverter is a device to convert DC from the array of a battery to a single or a three-phase AC voltage. So for understanding this system, first of all you have to understand what the basic electrical system is. And if you understand the basic electrical system, you will get to know how DC is converted into AC by using the single or a three-phase conversion. Now, storage batteries with a charge regulator are used to provide backup power sources during the period of a low solar radiation in the night. Okay, so this is the standalone system. Now, let us study about grid connected system. Grid connected PV system, it means connect to the commercial grid. Okay, so this system is generally used in household purpose. You are very awed to know this. Now it is on a small or a medium size system. Nearly will generate 3 kilowatt for the private residents. It means at the top roof we are putting our solar cells and solar collectors. It is just kind of a grid collector system, as you see in this diagram. Nearly 20 kilowatt for the housing colonies and 100 to 200 kilowatt for school and factories. Okay. The system operates on a principle of feeding power into the grid when solar generation exceeds the local demand and taking energy from the grid when required. It has no storage of energy, but it needs component to regulate voltage, frequency and wave forms. So at our household purpose, we are using the grid connected system. Now, let us have the solar satellite microwave power plant. Okay, generally in the solar satellite microwave power plant, the radiation is about very much 15 times larger than the Earth's surface at the satellite orbital area. Okay, so we have to use the solar satellite microwave power plant. So as you know, in whichever the space shuttle is there, it is using the solar energy only, and by using the solar energy it will generate the power by itself, because we cannot get any hydrogen or any other fuel sources at the space. We cannot use it, so we can only use the solar energy at that place, hence the solar satellite microwave power plants. Now first is solar diesel hybrid system, second one is solar electrochemical plant, and third one is solar chimney power plant. So let us have just a look of it. There is a diagram of solar diesel hybrid. Hybrid system, it means combination of solar as well as diesel. Okay, it can generate the electric power. A diesel generator only be used when solar energy is absent. Okay, during the daytime PV panels generate the electricity and power supplies to the load and also for the battery storage. During night, the energy is supplied by the diesel system. Okay, so it is the hybrid system as you see in the diagram. Now, if you see the diagram, if you see the arrangement of the system, solar PV panel generates the electrical energy. It is very simple. How to generate the electricity? You can get it. And the electrical energy is used for electrolysis of a pure water, which generates hydrogen and oxygen and other gases. To the storage tank, as you see in this diagram, the stored hydrogen can be used as a fuel. Okay, in a fuel cell, and also generate the electricity in a gas turbine. Okay, so this is the solar electrochemical one. How it works? So there is the water tank in which there is a water. Solar photovoltaic system will divide hydrogen and oxygen. Now this oxygen will just move into the atmosphere, and hydrogen can be stored, and by that hydrogen we can produce the electricity because it is used as a fuel itself. Now the next one is solar chimney power plant. As you see in this diagram, it is just like a shape of a chimney. Okay, and there is a tall chimney surrounded by a circular greenhouse at a base. Okay, and so many solar cells the arrays of a solar cell are put on that system. The greenhouse is supported by the metal frame and it is placed above the ground level. It has a glass cover with a transmit and independent, which can transmit and transmit the incident solar radiation. Okay, the radiation heated up the air and trapped in the greenhouse. It means greenhouse can be heated, but by putting the chimney, all the hot air passes through the chimney at the atmosphere. Okay, and the turbine is placed inside the chimney. So it is placed at the glass top and the chimney. In between that there is a turbine. Now what will happen? Radiation falls on the chamber. Now chamber may get heated because it is of a greenhouse effect, and the air inside it may get heated and it will flow outward by that chimney. And when they flow outward, the turbine will rotate, and by the rotation of turbine we can generate the electricity. Okay, now let us have some important point for solar thermal power plant. There are basically 3 points. First, choice of the solar collector and collection system. Okay, which is the first point. Second one, choice of a working fluid. And third, choice of a storage system. So let us first understand choice of a solar collection system or solar collectors. It is completely depend upon what is required. If we require less temperature, we can use flat collector. If we require high temperature, we can use paraboloid concentrator. If we require more high temperature, then we have to use cylindrical paraboloid concentrator. Okay, so this is just an example. With respect to the requirement, we have to use our different kind of collectors. Now second is working fluid. If we require less temperature, we can use the oil. If we require vapor system, then we have to use methyl and or any other fluid system. Okay, so it is completely depend upon our choice. Okay, how much temperature and for what purpose. We can use the ammonia also. So for what purpose we are using? Like in the refrigeration, we can use the refrigeration system for ammonia we are using. So if we need water heating system or a space heating system, we can use air or water or methyl for the higher temperature or power generation. So based on our requirement. And third point is storage system. Storage is also depends upon, it means we need to store the hydrogen just like we see in our chemical reaction plant. So if we want to store the hydrogen, we can store it. If we do not need to store the energy, we'll directly use it. Okay, if we want to use in a photovoltaic form, so we have to put the generators. So it is completely depend upon our requirement. So these are the important point for thermal power plant. So all these are different application. They are having very small kind of application. So students, thank you very much all of you for watching this video. If you have any query, you can contact me. And this all applications are really very helpful. Some are used and some are just the hypothesis. Thank you.